Fundamentals of radium and uranium removal from drinking water supplies, taking a look at Dennis Clifford, University of Houston, and he takes a look at the important radium isotopes right here and the important uranium isotopes. And he also looks at the chemical and physical behavior of these isotopes, seeing the 95% removal of the elements and 95% are present when they're together, regardless of the ratio of the initial activities, and 95% of uranium, and this is the most common one, 238 is also 95% of that when they're present together regardless. And they also took a look at radium and uranium specification in groundwater as a function of pH, and you can see the information here. There's a divalent caution, a neutral molecule, and a divalent anion as well. We also have the removal methods, and what are they? The caution exchange softening, BAT, lime softening, reverse osmosis, sulfone into minnow with HMO, precipitation into BASO or adding BACL, sorption into BASO impregnated media, and electrodialysis. And you can also see the removal methods for radium, reverse osmosis, caution exchange softening, sulfation into MO impregnated fibers or filters or granular media, and sulfation into BASO impregnated resin or activated alumina. And we can see the diagram here for radium removal by ion exchange softening with a bypass of blending raw water. You can see the blended product water, the bypass raw filter, the feed water contaminated with radium hardness, pre-filter if necessary, film-form resin, and the regenerate solution. We also have the ion exchange resins for radium removal right here, with designation with strong acid caution, resin for radium removal, amber light, dual light, and we have the resin description here as well, with the Lamont radium study. We can also see the process for somatic radium removal by absorption performed with H, M, and O. And for 50% removal in water with 10 picoliters, residual dry MO contains 21,000 picoliters right here. And we can see this for radium, the radium breakthrough, and we also have the uranium removal methods as well, which is the ion exchange BAT, lime softening, exchange coagulation, filtration, reverse osmosis, activated alumina absorption, and electrodialysis. And we can also see some of the removal methods with anion exchange, reverse osmosis, and activated alumina absorption. And the coagulation for remaining uranium removal here for 50% of the picoliters and the dry sludge contains, and we can see the effect of the pH as well on uranium removal by coagulation, 25 milligrams per dose. And also the lime softening for uranium removal, where 90% of the 40 picoliters and dry sludge contains 135 picoliters here. The effective pH lime dose on uranium removal by lime softening as well, and the ion exchange resins for the uranium removal are shown here. And the anion exchange for uranium removal as well. And you can also see the processes as well for the coagulation. How effective are they for removal? You can see 50 to 90%, a pH near 6 and 10, lime softening 80 to 99% higher than greater removal, and helps at the pH 10.6, anion exchange regeneration 2 to 4 MCL after 10,000 50,000 BV, and RO 99% effective but expensive. And also the residual information here. So that was a good scientific look at removing radium and uranium from drinking water supplies. How do you know if it's in your drinking water? Well, you have to have it periodically tested.